We are now going to use our definition of a logarithm to help us evaluate these logarithms. So right now, we're not used to logarithms. They're new for us. We are more used to exponential equations. So we can use our definition of a logarithm to change this to exponential form. We want to evaluate log 5 of 3,125. So we can say, I don't know what that's equal to, so I'm going to make it equal to x. And now that I have a logarithmic form of this, I can say this is the same as my base being 5, logarithm solve for exponents, so that's going to be x, equals 3125. And we can use the same techniques we learned in 5.3. I think even 3125 was even higher than we went on our powers of 5 chart. But 3125, can you write it as a power of 5? Right? We went 5 to the 4 to have 625. This is 5 to the 5. And once you get your bases the same, then your exponents have to be equal. Therefore, x has to equal 5. So we can use our same techniques that we learned earlier. I know this in particular, be careful with this, because this in particular, when I give you the pre-quiz, the way that the textbook does it and the way that the pre-quiz, help me understand it, does it is a little bit different, and I think it's a little bit more confusing. You can look at it for sure, and if you like it better, that's fine. But I would recommend using the same thing that we learned before. Sometimes if you use the same thing in 2 different places, it's less for you to learn, it's less for you to remember, because you're doing a similar technique. Same thing here, log 6 of 216. I would say, let's change this to exponential form. We know the base is 6. We don't know what the exponent is. All right, if we let this equal to x. Now, on the exam, sometimes they're fussy when you introduce an x that isn't there before. So it's not bad to say, let x equal log 6 of 1 over 216. So you're saying, this is what I'm going to make x equal to. I'm defining it, and then I can use it. Because if you introduce, there's an error on the exam that says, if you introduce a variable without defining it, it just came out of nowhere, they're going to take off a half a mark. So all you have to do to define it is have a little statement at the beginning saying, let x equal this. So I should have done that for the first one too. Just say, let this equal that. Everything's fine. Now I've solved for x, and you know what it's equal to. Okay? So here, 216 is on our powers chart for 6. It's 6 to the power 3. Using your exponent laws, 6 to the 3 in your denominator is same as 6 to the negative 3. Therefore, x equals negative 3. So log 6 of 1 over 216 is equal to 3. That would be a really nice way of showing your work and defining things carefully. I let x equal something, I solved for x, and then I can write a final statement showing that I evaluated what was asked. Yeah, here it should still be a negative 3. Thank you. Yes. If you just went from here to here, that would be fine. This is nice form because it asked you to evaluate this. So this last statement shows that you've evaluated that. If I just leave it as x equals negative 3, it's kind of a cryptic way of showing that I did that. And it does still do the same thing, but it's nicer form to show in the end that, yes, I know that I have now evaluated what I was asked to evaluate. It would be okay. Okay? So I'm going to let x equal log 8 of 2 cube root of 2. And so this means that 8 to the x is equal to 2 cube root of 2. Whew, this is the harder one, right? If we're trying to get things to be the same base on both sides, what base do you think we should choose? A base of 2. Can I change 8 to a base of 2? It's 2 to the third, and still would be to the x. And this is 2 to the 1 times by 2 to the 1/3. So on the left-hand side, I'm just going to have 2 to the 3x. On the right-hand side, I'm going to have 2 to the, what do we do when the bases are the same? We add them. How do we add fractions? We need a common denominator. Can you see the 1 is 3 over 3? 3 over 3 plus 1 over 3. This will be 4 over 3. Love late start Tuesdays. Totally thought she was late for class already. Anyways, 3x equals 4 over 3. Divide both sides by 3 is the same as multiplying by 1/3. So we get x equals 4 over 9. So again, I believe that this technique, because it's the same technique you learned earlier in section 5.3, is the best technique for you to use here. Change it right away to exponential form where you're more comfortable, and then use your skills to get your bases the same and solve from there. So I want you to work on these right now because this is the one thing I want you to practice. 4, 7, and 9.